Hello, good evening, everyone. Today I'm going to talk about API security. It's a broad subject area, but I will dive into the vulnerabilities, but I will touch base upon the entire breadth of it, but mainly I will be diving into the vulnerabilities and what you can do to mitigate some of those. So let me take you back to about 8 years. This is how I became interested in this area. I was developing a system. I was responsible for the authentication and authorization part as well. I had implemented Identity Server 4, and it was a project for US. We were doing it out of Sri Lanka. And then about 4 or 5 weeks afterwards, after shipping, the architects from there spoke to me and said, there's an issue, change this resource ID because it could be accessed by others. Then me being who I was and being the person who developed, you always wants to protect what you did, right? So I said there is authentication and proper authorization, and why are you saying it's not secure? So the story stops there, and it will continue a little later. So that's how I became interested in this topic. And let me paint you a picture based on statistics on APIs. Why APIs are under attack. So all internet traffic, API traffic is around how much do you think it is? API traffic. Any guess? So it's about 83% of the web traffic is API traffic, because all your websites, all your mobile applications, healthcare, you name it, basically our life runs on APIs, right? Everything we do, even to book a cab, you need APIs. So there's a huge amount of API traffic. And then on top of that, the Gartner says it's the number one attack vector. Why did it become the number one attack vector? From a security perspective, any guess?
Because it's usually accessing sensitive information like payment details.
Yeah, because actually, if you are talking about a cybersecurity attack, you need to do reconnaissance, weaponization, delivery, then you need to exploit. After exploitation, you need to install, then you need to set up a command and control center, and then you can take action. Basically, it's a very long set of activities. But when it comes to APIs, as you said, it's just you just find a vulnerable API and you have access to sensitive data. So that's why it is the very sensitive, it's the number one attack vector. Then, of testing, this is what we do. We do unit testing, we do performance testing, we do load testing, and all that. But when it comes to API testing, it is only 4% of the testing is related to security. So naturally, you will have a lot of areas exposed, right? And you can see some other data as well at the bottom. So that is why this is one of the, in terms of security, why we should consider about API security. Now let's talk about the attack. So you have all your web applications, mobile applications. You are using the interface, right? Then interface and the backend data is glued by the API. For an attacker, they go around the front end. They are not accessing your front end, but most of the time, your logic, your data filtering, lot of things happen in the front end. And it's where, so if you go, when you go straight to the APIs, it becomes extremely easy to attack the APIs and get into the data. And also on top of that, when there is scanning happening for cybersecurity, or even the source code, you do all that with the front end. Even the QA guys and everybody, SAST, DAST, Nessus scan, all those happens in the with the front end. Now, let me give you a brief about how these are categorized. So there are few categories in here. I will be talking more on these things in the later slides, but one is there are attacks related to authentication and authorization, which is basically identified as fraud. Then there is disruption because of denial of service attacks, and malware injections, data where data is extracted, right? So these are the three categories. Then there is the fourth one, flawed assumption of user behavior, where people abuse the APIs by using bots and various engines, allowing financial loss, right? Now, let me go into the details. One second, please. So I'm sure when you are developing web applications, you might have heard of OWASP top 10, right? So there is a similar top 10 for the APIs as well. So Open Worldwide Application Security Project, they have been doing this since 2019, and the latest version is version 2003. So they have identified top 10 security vulnerabilities related to the APIs. Okay. I'll go through each one of these one by one to explain the vulnerabilities, because that is where I was hoping to go into the depth, so that you know about the vulnerabilities and then we can talk about the rest. So broken object level authorization. We'll read it backwards. Authorization is not happening on objects, right? What do you think is happening? Does it ring a bell? In the first slide, I spoke about my story, right? I said we had authentication, we had authorization, but they were talking about a vulnerability and asked me to change the ID, right? The resource ID. Or if you are talking in terms of database, I was asked to change the primary key, right? So what happens here is user A, once they log in, will be able to access user B's data, right? That is what is happening. You have authentication, right? You may have permissions, but let's say your API says API /v3 / something ID equals 1111. Then you see that when you log in your financial data or something, then you change it to 1212. Is it going to block that? Is the system going to block it? No. Normally, most of the time, you will have access to it. If you do not have proper authorization implemented. So that is what this vulnerability is. I thought that 8 years back, I thought I had proper authentication and authorization implemented, but it was not doing the job that it was supposed to do. So what can we do here to mitigate this? So this is also known as BOLA. Um, so to prevent BOLA, conceptually, this sounds very simple, right? But actually, practically, it's very difficult to do this because you have to, sometimes you may have to give record level permission. Think how practical it's going to be, right? So most of the time you will need an authorization decision engine to provide that level of access or the restrictions. And and funnily enough, I later learned what that US architects had told me. They had told me a temporary solution to change the ID. Actually, it's a, so from the, there was a pattern in the key that I had given. So because of that pattern, like 1, 2, 3 or HJ 1, 2, 3, the pattern somebody could guess and change it to another ID and try. So instead of that, we put a GUID, which was temporary, but it's not actually really secure, right? So those are some of the things, those GUIDs, using opaque temporary IDs, or you can sometimes do having an ID in the JWT token. So those are all temporary but not real prevention mechanisms. The real mechanism, if you want to do, you need to have a authorization engine which will provide that level of security that you are expecting. I will show some of those going forward as a demo. Then broken authentication. Yeah, it sounds very straightforward. Your authentication is broken. So for broken authentication, there are, we talk about two different ways of broken authentication. One is missing, one is missing authentication, and the other one is broken authentication. Missing authentication is you have not implemented any authentication at all. Broken authentication is it has not been properly implemented. Like for example, in your backend code, I have this experience because even the first time I was doing, I didn't know much about all the flows and everything. I had to learn by doing. And when I was, so similarly, what happens is authentication is not always implemented by the experts. The developer who's developing will do it, right? But what happens is there are JWTs, there is JWS, there is JWE, lot of things involved in this whole security thing, right? Now, what happens is you will, let's say for example, this is one of such vulnerabilities that is there with the tokens. You will say, in your code, you will validate the token, right? Now, what happens is sometimes in some libraries with some languages, they are not actually verifying the signature in the token. Without verifying the signature, they will go straight ahead and say validation is okay. So what happens is if you are using that language and that library, you need to do it separately. So likewise, based on the library language that you are using, a lot of things can change. The way you authenticate will change, and you need to make sure that still you do it properly, right? So one of the things to mitigate is follow the best practices, use a proper middleware suggested for that language, for that purpose, and ensure that it is properly implemented. What else can happen? Okay, that is implementing authentication, but there are some more stuff. You can have weak API keys that are not rotated, okay? So that's one thing. Weak or blank passwords. There has been a situation in a financial organization, the password has the length, all these character requirements, everything in the front end. But if you access the API, You can just register a blank password and go forward. So weak passwords, which will allow brute force attacks and various other attacks. Poor access token validation, as I mentioned. Credentials and keys sometimes are passed in URLs. They are only encoded by base 64, and there is no encryption. So a lot of things, so that was a list of things that can go wrong with authentication. So to prevent, make sure that it is properly implemented. Then broken object property level authorization. Okay, so we had BOLA, broken object level authorization, broken object property level authorization. This vulnerability category features in nearly all high-profile API breaches. This is also known as excessive data exposure. What happens is, why do you think people expose more data with the APIs, the developers? What makes them do it? So we have a fantastic glue between the developer and the database. What is it called? ORM. So we have an object relational mapper that will provide the entire database as objects to the developer. So what they do is when they are developing APIs, they straight away convert that objects to JSON and release it. Then where do they get filtered? They get filtered in the front end, where all the attackers bypass. So that is a very, I would say, dangerous or big vulnerability. That's why it is happening everywhere. So avoid doing that. Make sure that you give only the data that is required for that function as a response, right? That is what you can do to prevent that. And on top of that, there is another thing that you can do. I think even I am a culprit. We straight away start developing the APIs. But the suggested best practice is to do the specification first, open API specification. So if you have a complete specification, then you can avoid these things happening because you are working with the data governance, because you can't expect a developer to do it, right? So the data, you can't expect the developer to know how sensitive some data is. That has to come from the data governance side, and they have to tell which data shouldn't be exposed, and you need to work with them and ensure that unwanted data doesn't get exposed. Let's move into number 4. Unrestricted resource consumption. So this is related to where an attacker would submit a very high volume of data to the APIs. It could be a brute force attack on the passwords, or let's say they identify some pattern. Let's say, for example, a tracking number. They all have patterns, right? Date, something, something. So if you identify a pattern, you can keep on brute forcing, and that is when this vulnerability happens. Unrestricted resource consumption. What can happen is the service will go down as a fact of this happening. And the other, there is another bad thing that can happen to a business that is API based. That is, let's say you have given a quota to your client A, and because of the attack, his quota for the API is over. Your service allows them to do something, and you are measuring the quota, right? Because you charge them for the quota, and it's gone. Then it's very bad for the business. So you need to make sure that you do rate limiting. You can do rate limiting in the API backend code as well as in the API gateway, and also have a defined dedicated API firewall. So, but the thing is, this is something that I want to highlight. I will speak about this little later as well. Even if you have a dedicated API firewall, if you do not have the open API specification, there is no point, because the firewall is going to rely on your specification to decide what to block and what not to block. So if you don't have a specification, but somebody from the system side or infrastructure side goes and implements the API firewall, it's not going to be really helpful. That is why you should always start by defining the APIs and developing afterwards. And also, even if you rate limit, the skilled attackers can bypass them using spoofing IP addresses, using distributed attacks, changing clients, having bots. It could be done. So you need to make sure that your APIs are solid and well protected anyway. You can't rely on this alone. Broken function level authorization. Funny names, isn't it? Here what happens is, user A is able to transact on behalf of user B. Again, similar to the first one. Now, first one, only view. So it is sensitive, but this is extremely dangerous, because user A is able to transact on behalf of user B. How does this happen? Again, in your APIs, you will have something slash API slash B3 slash user slash something and get. If you want to, let's say you are giving some images, okay? Now, as a developer, let's say the admin can delete those images. What would the developer do? They will develop an admin API which will have a very similar path, and instead of the user, it will say admin. Now, if the authorization is broken, the attacker will, instead of get, he will put or patch it and change that admin. These are actual vulnerabilities, right? This is the 5th in the list. So this is happening worldwide. So they will change the admin and the same number. Then the resource that cannot be deleted will get deleted. So what you need to do is, you need to make sure that you have claims within JWTs and you do proper authorization with that, or else you implement RBAC to ensure that broken function level authorization doesn't happen. Okay? I know this is, at least I find it difficult to keep on talking, but I'm going to finish it soon. This slide, and we'll move on to a demo or something. Unrestricted access to sensitive business flow. What is this? Somebody will identify a sensitive business flow. Are you able to recall any such incident? Okay, I'll give a clue. PS5. Does that ring a bell? Can you remember for PS5 shortage? Lot of people were struggling to order them online. So this is what happened there. Attacker would map the flow. It's very easy, right? They would identify what APIs are called in what order. They would map the business flow, and then instead of using the site, they would write a script to do the ordering. And after that, they were selling the PS5s for double the price in the internet. So this is the vulnerability that happened there. So you have to make sure that the business flow is protected, one, and if this is critical and used by consumers or something like that, you can use the capture to ensure that it is carried out only by a human and not by a bot. And what else can we do? We can do device fingerprinting to ensure that headless browsers are not accessing them and running the script. So quite a few things like that can be done, and non-human detection patterns can be applied. Like for example, if it is a human, you click on the item, you look at it, you add to the cart, maybe 1 second, 3 seconds. So if it is happening like at a half a second, the entire process is happening, you know that it's an attack and you can block that, right? Then comes server-side request forgery. So this is where you provide a URL to the API endpoint, and the API, functionality of the API, will use that URL to access some resource. What an attacker would do is, if there is no proper sanitization of the URLs, validation, if all those things are not happening, an attacker can provide a URL which will turn your service into a proxy and carry out malicious attacks, or else hold the entire service from functioning. So a lot of things of that nature can be done. So ensure that you have a love list. Remote origin users are expected. So let's say, for example, if the provided URL is supposed to download from Google, let's say Google Drive only, then do a allow list. Don't allow any URL to be provided into that input box. Okay. So if there is an accepted media type, let's say it's only a JPEG that you are allowing the URL to access, ensure that it's only a JPG that can be accessed with the URL. Don't allow some script to run. Use a well-tested and maintained parser. So those are some of the things that can be done here. Then comes security misconfiguration. So this can happen at all the levels, from infrastructure to the servers that is hosting everything. And also it can happen in the APIs, like misconfigured header, misconfigured transit encryption, use of default accounts, acceptance of unnecessary HTTP methods. I will show you in a demo. Lack of input sanitization, and also verbose error messaging. So one of the key ways of identifying errors is when it provides a verbose error message. You can easily find a vulnerability and carry out the attack. Then improper inventory management. Always maintain a proper inventory for your APIs. Have it properly documented, what it can do, what it can't do, what is the request, what is the response. Have all those things properly documented in the Open API specification as well as in any other documentation format. So that is what inventory is, because sometimes what happens is for most of the organized, like I can't remember the exact number, but for about 50 or 60%, they do not know about all the APIs that they have, because there are so many systems and they have no clue about all the APIs that they have. So one of them could be vulnerable. Use of unsafe consumption of APIs. This is where we talk about using third-party APIs. So if you have a security posture, ensure that your third-party APIs that you are using in your system are secure to the same standards. So that is the list of top 10. So I think I spend a lot of days to go through these. So anyway, let's move on. So what I will do is I will show you a small demo. Hope you can see this is from Portswagger Web Security Academy. I am using Burp Suite to do this attack. These are labs provided by them. They are all free. You can download the community version and carry out these attacks and learn for yourself if you are interested. So what I am trying to do is this attack. Finding and exploiting an unused API endpoint. Okay, so that is what they say it is. Now, oh, this is down. Let me restart the lab. Okay, the lab is on. So what it's asking us to do is to solve this endpoint. There is a leather jacket. Log in and buy it. So I studied cybersecurity at the University of Sydney for a course. So at the beginning, they always tell you not to do this on actual stuff, right? Or other people's softwares and all that. So I also would like to remind you, please try it in a lab. Don't try these at so this is what we need to do. So what I will do is I will log in. So now this browser is part of this Burp Suite product. So all the traffic that I am accessing from the browser is going through this software. Okay. 0A. A8. So I am going to add this to the scope, and I am going to look at the traffic. So this is all that is coming from that website. So what I am going to do is I am going to log in as the user that is mentioned here. Vena is the username, Peter is the password. Okay, now I have logged in. So all that is captured here. I hope you can see this login and all the other get methods. Now what I'm going, sorry. Now I'm going to the home site. They are asking us to buy this jacket, which is $1,337, but our score credit is 0, right? Then what do we have to do? Sorry? Yeah, we have to add it to the cart. Okay, we'll do that. Okay, it's in the cart. It says cart has one item. Then now we can't buy it because we have 0 credit and this is 1,300. Let's place the order and see what happens. It says not enough store credit. Then what do we have to do? Have a look. There is a coupon also, but it's telling us to buy this. So my feeling is, based on the name of the attack, we have to make the price of the jacket 0. If we do that, then we can buy it, right? Okay, so let's do that. Now, if you look here, look at the methods that are there. If you look at the APIs, can you see this API? There is API called API product 1 price, right? So I will send this to the repeater, which will allow me to repeat this API call. I will send it and see. Okay, it's saying price is this, and it's providing me with a message. I did increase the fonts. I hope you can see to some extent. Yeah, now this is a get method. This is all we can see, right? That is the only API that you saw. Now, what we can do is, okay, I am not going to pretend that I don't know it. I did it, so I know the process. But you can do a few things, go around, find APIs, come back and do it. So there is a method called options. So it's advised to block other methods, right? That is what I told you in the top 10. So we send it. It's saying method not allowed. But what else does it say? Allow, get, and patch. The header, in the header, you are getting the message saying this endpoint has both get and patch. We used get. Now we have to try patch. Let's send it and see. Client error. Only application JSON content type is accepted. What have we got to do? We have to copy this and paste it here to make it application JSON, right? I'll paste it somewhere here. Doesn't matter. And since it is a request, let me put a JSON object and let me send it now. It's saying client error, price parameter missing in body. So the error is telling how to attack, right? So what we have to do is now say ERIC. Price and 0. So if you do that, then price becomes 0. So let's see if we have solved the problem. So we go to the, sorry, okay, the price is now 0. You go to the cart, remove this expensive one, go to the home page, add to the cart, then go to the cart and place the order. So you saw the attack, right? So make sure that your APIs are protected and these kind of things cannot be done. Okay. So I'll do another one. So I spoke about mass assignment. What is this? Anybody remember this? This is related to the ORM, where you provide more than required information. Okay, mass assignment vulnerability. So we'll access the lab. So you can see this. Oh, sorry, this is not going to happen. One second. Okay, it got captured. So this is the one that we are concerned about. 000A44, this one. So I will add this to scope so that we can check this. What does this say? So it's telling again to is a mass assignment vulnerability to buy the jacket by logging in. Okay, same thing but a different approach. So let's go and again try to buy this. So we got the same error message. Let's look at the APIs. We have an API called checkout. So we are getting this object. We can't go with a get, right? Let's see if there is a put method for checkout. Post, sorry, there is a post. So let's go with the post. It doesn't do anything. So what we have to do is, so it's when it is checking out, there is this object, the product ID and the quantity, right? If we are doing, we had the same thing for get. So what do you think we should be doing? Let's put a 100% discount. Then the product will be 0, right? So if it is a mass assignment vulnerability, look at the post API. For the post, it's only this part that is available, right? And the get has more. So let's copy this. And put it here. Now we have a different object altogether. Everything is good. Yeah. And then instead of the discount percentage 0, let's make it 100%. That's the only way to buy with 0 credit, right? And now let's post and see. It says created. So we have basically bought the product. That is the mass assignment vulnerability, right? So there are a lot of vulnerabilities like that. So make sure that your code is secure. And let me take you through a few more slides. So API breaches. If you want to know about API breaches, go to this firetrail.io site. You can see a lot of an API data tracker. This will have all the breaches listed there. So look at the names, guys. You can see USPS, Facebook, Trello, Instagram, Dell. Do you think they don't have enough tech, enough cybersecurity prevention mechanisms in the network? We don't think so, right? Then what is the problem? But the APIs are not protected properly. So even though they have a lot of other mechanisms to protect their data, they do not have enough security or the enough testing to protect their APIs. Now I'll take a few more examples. This is also a very interesting one, which happened to Coinbase. So as you can see, so this guy did not have Bitcoin. He had an account, this researcher, a security researcher. So he looked at the API. He had Ethereum, and he wanted to sell Ethereum and buy euro. Okay. So he had the amount. He was using the front end and doing it, and he came across this API. And then what he did was, instead of ETH and EUR, he changed it to Bitcoin, BTC, and USD. And what happened? The sale went through, and he got, similar to what I did earlier, he captured the API points, endpoints, and made that request. He did not even have that pair, Bitcoin and USD. But still the sale went through, and he got US dollars. And then he reported this issue to Coinbase. And so what is the point here? Your UI is not part of your security stack. So do not do unnecessary or security related filtering in your UI. That is not where you are supposed to do. So this is a missing validation logic. It's not doing enough validations to see if you have that pair. Because the UI, sorry, QA guys might have checked using the front end and this got missed. So that's it. Then Peloton, you might have heard of this. President Biden trying to get his treadmill into the White House, and there was a big issue. This is the broken object level authorization, user A being able to see all of user B's data. Again, authentication and authorization are two different things. Both needs proper implementation. So that's the message that I can tell on this one. Then there is another interesting one related to Australia. You know about what happened at Optus. Data breach of 40% of the population. And there was a funny story, but it's both the people are correct. What they are saying is correct. But there is, look at what the CEO is telling. She's telling that it was an extremely sophisticated attack. But was it? A simple API was open. It did not have any authentication. And the attacker was able to access all the data. So your the Australian Minister for Security says it's a simple attack. Then again, the CEO says, no, we had very sophisticated protections. But it doesn't help, right? Actually, it's a open door. That's why an inventory is important, and you have to know what your APIs are doing and how to protect them. So 90% of the attacks happen in the first 1, 2, and 3. So ensure you do your authentication, authorization, all those things properly. And you need to have a proper strategy for offense and defense. The interest of time, I'm not going to go into detail, but have a good governance mechanism and cover all these areas. And so you will be good. And in terms of security, in terms of testing, you are always testing, does it do what it is designed to do? But you never check, does it not do what it is not designed to do? That is related to the security point. So thank you very much. Thank you, Clee, and thank you, team, for listening to me. That's it.